All right, welcome back. So in the last set of videos, there was this problem that included a step function. So we're gonna talk about how to deal with that here in 7.6. So let's start just by defining the step function again. So the step function, okay, u of t, that just equals 0 if t is less than 0 and 1 if t is greater than or equal to 0. Okay? Actually, here it says greater than. Really, it does not make a difference. We can have it undefined at 0, or we can have it defined at 0, one of them. It's not really going to make a difference when it comes down to it. Okay? So let's go ahead. We're going to take the Laplace transform of the step function. So we're going to do this. We're actually going to take the Laplace transform of the step function where there's like a t minus a, let's say a. So let's let a be greater than 0, and we're going to take the Laplace transform of u of t minus a. All right? So this equals the integral from 0 to infinity, okay, of u to the t minus a e to the negative st dt. All right, and now since what's going on here is u to the t minus a, that equals 0 if t is less than a, and 1 if t is bigger than a. All right, so we're going to rewrite this integral as the integral from a to infinity of e to the negative st. Okay, so now there's a couple ways that we can do this. We can just do this integral directly, actually. Okay, yeah, we're just going to go ahead. We can do this integral directly, but I'm going to show you a trick that we're going to use for a lot of these. So what we're going to do, we're going to do just a quick substitution. So let's let our substitution, let's call it tau equals t minus a. All right, tau equals t minus a. So now if we make that substitution, then we're going to get, this is the integral. Now, when t equals a, tau equals 0. So we're going to have from 0 to infinity, and then we're going to shift on the exponent, right? Because it's going to be e to the negative s, and instead of t, it's going to be tau plus a d tau. I know it seems a little roundabout the way we're doing it, but there is a purpose, okay? Because it's the method that we're going to use to do a lot of these problems. So now we're going to have an e to the negative sa pulls out, the integral from 0 to infinity, e to the negative s tau d tau, and then this is our usual Laplace transform of 1. Okay, so this gives us e to the negative sa times 1 over s. Granted, I could have done that just from here, you know, I could have just integrated e to the negative st over t, over s from a to infinity. And then if I do that, I'm going to still get this. Okay, so I'm aware that I could do it that way, but I just wanted to do it this other way because some of the other integrals we're going to do. So let's do one of those other integrals. Let's do, this is actually number 10 in our, I believe number 10 or number 11 in our Laplace transform list. So number 10 on the list or on the table. that we used in class in the last set. Okay, and that says the Laplace transform of f of t minus a, u of t minus a equals e to the negative as f of s. Okay, so let's go ahead and show that. All right, so let's take this. This is the integral from 0 to infinity, okay, of e to the negative st f of t minus a u of t minus a dt. And now we're going to do that same trick that we just did. So we're going to take and we're going to let tau equal t minus a. All right, so if we do that substitution, this goes from now a to infinity. Our t, it becomes tau plus a. Okay, f of t minus a becomes f of tau. And then the u of t minus a, I can disregard it, okay, because it's equal to 1 on that whole interval. Okay, so now I'm going to go ahead and pull out the e to the negative sa. That doesn't depend on tau, so that's not in the integral. Okay, the integral, oh, I did too many things there. Let me put a step in, because this is actually not right. Let me put this step in. This is actually from a to infinity, e to the negative st, f of t minus a dt. Okay, then we're going to make this substitution. Oh, sorry about that, guys. Once I make that substitution, this a down here is no longer a, because when t equals a, tau equals 0. Okay, so now it's e to the negative sa, the integral from 0 to infinity, e to the negative s tau, f of tau, d tau, and that's the Laplace transform of f. Okay, so here f of s is just the Laplace transform of f of t. Okay, all right, I'll see you all in the next video.